Hi DX, I've posted the slides on chat. Kindly please share for me because it seems my system has an issue.
Okay, you mean I should share my screen from here?
Yes, so
Okay, that's
open the
fine.
slides and then share the screen for me.
Okay. Okay. Is my screen visible?
Yes, it's very visible.
Okay.
Thank you so much. Yeah, thank you so much for sharing. Okay, guys, hi. I'm Deacons. They call me Decode, and today we're going to have a Cairo security workshop. The way we've arranged the workshop, it's supposed to be a 30-minute session twice a week, so we'll have a full hour every week for the next 4 weeks. And I think more information will be given at the end of the session. So today's session is supposed to be a very easy interactive session, right? So we are going to just talk in generally about Starknet. Why do we need it? Is it necessary? Some bit of information regarding zero knowledge proofs, and then on Friday is when we will delve deeper into the technical bit of it. So today is more about building context or understanding regarding why Starknet is needed in the first place, right? Again, if you have any question, kindly feel free to post it on the chat, right? Sorry, have a bit of a cold.
Next.
Now, so, hello?
Yeah, go on, please.
Perfect. Okay. So, we have a little bit of a blockchain paradox, right? First, we need to know. They say necessity is the mother of invention. You have a problem, you try to solve it, right? So, which you have that mindset at the back of your head as you're going through this introduction to Starknet and zero knowledge proofs, right? So we have a blockchain paradox. We know Bitcoin was launched in 2008, Ethereum in 2015, but we have a very huge problem. We are very slow compared to banks, credit cards, and even Alipay, right? Now, to bring this into context, the highest ever recorded transactions on Ethereum, the very highest that we ever recorded, was around 1.9 million transactions on Ethereum, around early this year, actually, around January 14th, right? You can get this data via Etherscan. You just go to chat transactions. So the highest number of transactions, that was on 1.9, right? So even right now, with that, we understand that at the peak of transactions, at the very peak, it is 1.9. Now, to bring it into context, we can compare it with, I think the slides can go back a little bit. Yeah, so to compare it with normal banking system, we understand that for the year 2022, you can do your own research. It was north of, just credit card transactions was north of 625 billion. So that is roughly around 1.7 billion transactions a day, right? So the Visas, the MasterCards, all these things, their transactional volume is very high. Now, in as much as we love Ethereum for the decentralization, how then can it be able to solve normal problems that we have, right? How can it be able to basically work towards this huge number of daily transactions that are needed in the entire global financial sector, right? Now, you understand with Ethereum, the higher the number of transactions, if the transaction is very high, if there's a lot of demand on the network, it means there's also an influx of gas fees, right? And we also know that not all transactions are basically adding the network. It means if you have a lot of money, you'll be the only one who will be able to to be added into the network. Now, that is the problem that we have with Ethereum. It is a very beautiful technology, but it cannot serve the financial needs that the world needs right now. We can move over to the next slide. So we have that aspect, but again, now why is Ethereum so slow? Why is it so slow? We understand that the banking system, they basically use a central serve or a single trusted entity, which basically does all the transaction, right? But with Ethereum, we have something. So with banks, we know it's the delegated accountability, right? You don't care about how your money moves. You just go to your bank account. You just see your amount is there. You can transfer to send a bill. Let's say someone like Evans, and he receives the accountability, basically. Now we can move over to the next slide. Yes, now, this is the problem with blockchains. Now, not the problem per se now. The essence of blockchain and decentralization is we need to have inclusive accountability. It is no longer delegated. It means that every node in the network has to verify the same transaction over and over again. So you can have 100 nodes. These 100 nodes will have to verify the transactions. So if I send money to, let's say, someone like Andre, and we have 90 nodes. Each and every 90 node will have to verify this transaction to Andre. They'll basically do the same job over and over again. So it is more of it's just repetitive activity across the network. Now, because it is very repetitive, again, our ethos is you have to verify all transactions because it's blockchain and decentralization. Do not trust any single individual. Do not trust everyone. They have their own consensus mechanism that we agree on what is on instead. So the aspect of inclusive accountability, again, it brings some little bit of lag with the way or the efficiency and simplicity of how transactions are going to happen, right? Now we can move over to the next slide. Okay, yeah, thank you. Now, so because blockchain basically we don't trust, we verify all transactions. It means, as I had said, all nodes will have to verify every transaction. So if it is 5 transactions that are supposed to be added into the network, every node has a copy of the same ledger. So there's no everyone must have a copy of their own ledger, and they have to go back to this ledger. Now, the issue of inclusive accountability, we are sacrificing privacy in a way. Privacy in the essence that everything that is put on the Ethereum network is public, right? You can basically query every transaction that you want, and you're able to see. We're also sacrificing scalability, right? It means that we are unable to scale Ethereum as quickly as possible. Again, we are unable to compete with the traditional financial systems that the ethos of decentralization and blockchain technology when it comes to decentralized finance was supposed to kill, right? Okay, we can move forward to the next slide, please. Yeah, so basically this is what we have right now in comparison. So we have the banking sector where everyone just, there's a central authority where we've delegated accountability to, which is the banking industry. Or we have our own Ethereum network as is, where we have nodes, we verify everything, we don't trust anyone, and basically every transaction is run by I think there's noise from Guild Code. It's
let me.
So okay. Okay. Now, so to this, again, at this state, what can we do? I think we should just go back a little bit. Okay. Yeah. So, what are the options?
Sorry, let me turn off my mic.
Yeah.
I think I need to.
what would be the possible solutions to this problem that we have? One problem or one potential solution to this issue can be, you can argue, right? How about to increase gas limit or the block limit, right? We know that transactions are bundled up into blocks, and this blocks is what is mined, previously mined, but right now it is what is stacked into the blockchain, and then every block is tied to every block. That's why you have something called a blockchain, right? So we understand that we can increase the block size, which basically allows us to add as many transactions as possible to the block. Now, what are the drawdowns or the challenges to that? That would mean it would consume high computational powers, right? It would mean that we would really trust big computers, right? And therefore, this would zone out or prohibit normal individuals such as me and you to be able to run our own nodes, because again, if you increase the block size limit, it means it takes high computational capabilities to be able to add a block into the chain and to hold everything else. So it means that you'll need to trust a very big, fast, and very expensive computing system, right? That means that the entire blockchain system will be exclusive. It will be exclusive to certain individuals. Now, the second flavor to a solution is what I think most of you have also interacted with, is having something called fraud-proof rollups, right? And now this is where we come into rollups. So basically what rollups are, they're just that. You roll multiple transactions into a single transaction, and then you're able to use this transaction. Now, how is it possible? It again comes back to what is Ethereum. We understand that Ethereum is an EVM-based machine, and it is a state machine, right? So the only thing that Ethereum cares about is the state, right? It doesn't care about how many, for example, if I send money to Okoli and he sends back the money and I send it back again to him and he sends me back the money over and over again, Ethereum does not care about this back and forth processes. It only cares at time X or at time T who has the money, right? So it is deducted for me, increased on your end, deducted from me, increased on my end. So we understand that the most important thing within the Ethereum, within Ethereum, is that it is a state machine. The most important thing is the state at time T. So at all times, what is the state? It means if it is in terms of asset exchange through sending some sort of value or receiving some sort of value, it is at point T who is the owner of this value and who is the owner of this other value, right? So we understand that. Now this, because it is a state machine, it allows us to be able to bundle transactions, multiple transactions into a single transaction. And this single transaction basically is just submitted to the Ethereum layer as the base layer to update the state. Because again, the only thing we care about is the state. We don't care about back and forth. So fraud-proof systems like a Arbitrum or Optimism, this is how they work. Transactions will happen in L2, and then it will be rolled up into a single transaction, which will be submitted on layer 1. And then if there's an entity that thinks that this transaction should not stand, then you are able to submit a fraud proof, and then the entire transaction can be rolled back, right? So if a certain state is updated, and then we think that state or there are certain transactions in there that are not valid, it can be rolled back. So you simply submit, I think transaction X is malicious and should not update the state as is, and then it can be rolled back. So that's why it's called a fraud-proof rollup. And again, we won't talk much about it today, and I think maybe at your own time you can dig deep about what is Arbitrum, what is Optimism, etc. And again, we are all in the race of trying to scale Ethereum now. We can move on to the next slide. Good now. So the second flavor that we are largely talking about is something called validity proofs. right? No. Now, so validity proofs, basically right now there are two huge flavors. We have ZK Sync and Starknet, which are ZK Stacks, right? I won't talk much about ZK Sync because I genuinely haven't done a lot of research about it, but I just know ZK Stacks have a little bit of advantage towards ZK Sync, ZK Snacks actually, because it's quantum proof. But for more information, I think you can pick now. Basically, what validity proofs are, so we have a single entity that generates a proof, right? Okay, now, so initially, through fraud proof system, we had a big computer which generated proof, and again, semi-inclusive because not everyone can participate. Now, with validity proofs, any individual, including you and me, we are able to verify a proof. And it is very fast and it is very inclusive because it's not expensive, it is not highly computational expensive. Anyone can verify a proof. Now, we can move forward to the next slide. Now, so these are the two most important entities to a validity proof. You have the verifier, which verifies proof. You have the prover, which generates proof. These are the two most important participants of this. And then you have a proof. A proof is a statement. You're saying X amount of computation was spent looking for this solution. Like this was like in proof of work. We needed to do a computation, and then you submitted a hash showing that you indeed that was the correct hash, and then it was added. But right now we have proof of stake, right? So someone is chosen from the network to submit, right? So with proof, you're simply submitting a proof is a statement saying that a proof is a statement saying that these states, Ethereum states need to be changed to this, and you're just proving that I've done this computation and this is the valid state of the network, right? Now the prover is the party producing the proof, right? So the party producing the proof, and the verifier is the party checking the proof. Basically, they are the nodes, right? Now, an interesting thing about validity proofs is instead of everyone submitting a transaction to Ethereum directly, these transactions are bundled up into a single transaction. Now, by the time the proofer submits a proof to the verifier, which lies on L1, the verifier will be able to get a single transaction which contains all this state. Right? Now, that is where scalability happens, because assuming, let's say we have 1,000 transactions, and each transaction roughly on average costs, we needed to spend like $10 per transaction, right? And we have 1,000 transactions from 1,000 different entities. It means that roughly you're spending $10,000 for these 1,000 transactions. Now, if you're able to bundle up this 1,000 transaction into a single transaction, it means instead of spending 10,000, you're spending $10 for this transaction. Now, the better part about it is this $10 is distributed among 1,000 individuals who want to send a transaction. Now we have distribution of costs in terms of a single transaction is, so all transactions that are contained in a proof, the cost that lies with it is able to be easily distributed, right? Now, move to the next slide, please. Yeah, so ZK stacks are basically zero knowledge. And I'll have to explain the concept of zero knowledge, but as you can see from the slide, it's the exponentially smaller verifier running time, and basically you're just submitting the state, right? So the proofer bundles up the transactions and just submits the state to the verifier. The verifier will have to prove that indeed these are valid state changing actions, and then they are able to be accepted, right? So move on to the next one. The next slide, please. Yeah, so again, now what is submitted to the Ethereum network right now is just states, right? So we verify stack proof. You don't trust anything, you still hold the just verify a stack proof. Now, what is zero knowledge proof? Well, I think I'll use this period to explain what a zero knowledge proof is. So a zero knowledge proof is embedded in cryptography. We are basically, one, it is zero knowledge. It means the two parties, the verifier cannot know any information, transactions, or what is contained in the proof. It cannot even know the inputs of the proof. And if any information is leaked, is not even regarded as zero knowledge proof. Now, I can use an example to explain what it is and how it works. So we know the verifier lies in L1, right? It verifies the information. It does not know, it should not know the contents of a proof. It should not even know the inputs of a proof. Now, so we can say the verifier, let's say it's a colorblind person, someone who does not know any color, right? The prover, they're the one who produces the proof, so they know different colors, right? So the prover can submit to a verifier 2 balls. Let's say you're the prover and you have your friend who is a verifier and they're colorblind. They don't know different colors. You provide to them 2 balls. One is red and one is black. You give them the 2 balls. The work of the verifier is, one, to verify the authenticity and validity of this proof that you submitted. Now, how will the verifier do this? So the verifier will test if you know the inputs if you know the type of balls that you've given them. So they'll hide it in the back and they'll present it to you. They'll tell me the different colors. So you'll say hand 1 is black, the right hand side is red. And then now that is 50-50. So the verifier will, okay, I'm not sure, maybe they'll get it back into their hands and then they'll like show it to you. You as the prover, you'll be able to tell them because you're saying hand left now is red, the other one is black. Now, the verifier can ask as many questions as possible. They can ask you, the prover, as many questions as possible for you to prove to them that you know the proof that you submitted and in the right state without them knowing. So it is highly based on probability again, right? Mathematical probability. So the verifier has the ability to ask as many questions as possible until their degree of certainty is reached, right? So if the verifier is satisfied that indeed I think you know that these are indeed 2 balls and they have different colors, so they can switch it and give back. So that is the entire concept of zero knowledge proofs, right? So the verifier does not need to know anything. The prover is able to generate the proof, and the verifier can ask the prover questions, and the prover will be able to prove that the authenticity of these proofs, right, through mathematical computation and cryptography. Okay. Up to there, any question? Okay, maybe we can move to the next slide. Yes, so that's it. I really tried to fit into our 30 minutes schedule and I think I've done extremely well. So I'm 27 minutes in. Again, yeah, it was 30 minutes plus, and that's in. So any question at this point? Any question or any suggestion? Feel free to post into the chat. Feel free to ask DX over there. You can text him the questions. You can even write all the questions, and then we can talk about them some more as we're preparing the content for our Friday class. You can do all this. Yes, so if there's no question, that's it from me for today.
I'm sorry, hello.
Yeah, go on, please. Yeah.
Yes, I want to ask. I'm not really directly at this, but I've always been looking at him. I've been trying to study the whole ZK thing on my own, but then I realized most of the what I've seen outside have always been math heavy. So that's always been like my own fear. So I wanted to ask, how much do I really need to like comprehend these things to a decent level?
Yeah. I'll also be honest with you. It's not like I know everything. Even the math heavy stuff, I genuinely don't know. I haven't even studied the polynomials that comes with zero-knowledge proof. But this is what I'll tell you for free. It's a fairly new technology. We are having content that is like educational contents. Actually, this year and last year is where the contents actually increased. If you did Cairo 0 in 2022, it was hectic. Little as there were just little resources. So fast, don't feel like you are new. Don't feel like you're overwhelmed, because I can assure you, probably Eli and the founders of Starknet are the ones who know everything about Starknet in itself, right? So everyone is trying to learn and understand. So one, you're on the right track because it's a fairly new technology. Two, what you should do, just start with the basics. For example, what really helped me, or what is really helping me, I have an understanding of what Starknet is, and then you just build from there. Learn about Cairo, and then because Cairo, we know it's a provable language. It's not a normal language like Solidity or Python or anything. It's a provable language. What does that mean? It means that you get proof to write proofs with it. So you just learn about Cairo and then build projects and then learn more. It's basically that's it. But you just have to be consistent about it. But don't feel like you are new, you don't understand everything. Boss, no one understands everything. That is what I can tell you. And I think you're in the right track by first trying and also attending such boot camps and online classes. And then just picking it up slowly by slowly. But just be consistent about it. You'll be okay.
Okay, thank you.
Yeah, just to add to that also, so just like what he said also, to put it on that point, just keep showing up on what you want to do. Just keep showing up, be consistent. That's the word. Just be consistent. So also for the math stuffs, so at Guild Audit, we also train cryptographic engineers. So we take it from ground up, from the scratch down to a level of advanced parts. So like we go even down to polynomials, and it's like from cryptography, like we start from cryptography, from basic mathematics. So it's just purely cryptography mathematics. That's what we're doing also. That's part of our curriculum at Guild Audit. Just to note on that. So at the same time, please join several communities. I think there is the Starknet Africa community, and also you can also join our Guild Audit community to get to see some of the resources we'll be putting out there in terms of the math stuff. But also, just like what Deacon said, you could just start from some of the resources that are out there already, understanding Starknet, understanding Cairo, right? Even without going in depth the maths part of it. But yeah, why not? If you know the math stuff, it's also a good thing to have. Yeah. More questions, guys?
Yep.
Okay, good evening.
Good evening. Hi, Karen.
Yeah, I'm good. I wanted to ask about, I don't know if it is, if since we are not, but I just want to kind of ask you guys an optimistic rollups. You mentioned about the fraud proof being optimistic, that whenever, you mentioned about the rollups being optimistic, that whenever somebody detects a fraud and the state can be reversed. I'm just kind of confused at that point, that if the state is reversed at that point, is it going to affect only that particular state or other states that have been updated after the main state?
Yeah, so I to be honest, I don't know the technical aspect of it. Like, I haven't gone, there's no L2 that I have additional knowledge like the one that I have on Starknet. But what I just know in terms of the difference is because again, Arbitrum uses validator, so a validator can submit a fraud proof if they believe another validator has added a bunch of transactions which are invalid, right? And this state can be reversed. So you just submit a fraud proof regarding a certain transaction, and then states from those transactions are able to be reversed. But depth knowledge about how the mechanics of how does it work, to be honest, I haven't looked at it. I just know in a layman's way that is how it happens. So I think maybe I just urge you to maybe look at it. But for me, I really haven't gotten time to dig deep into how this is happening.
Okay, no problem.
Okay.
So
I guess there is no question more. Thank you very much, Dickens. This is really a nice one and an awesome class. Yeah. So thank you guys. Just to give more in depth on what we do at Guild Audit and what the goal and the future of this program. So first at Guild Audit, Guild Audit is an security Web3 security firm. We also do security for projects, and also we train security researchers, like developers that also want to become security researchers. So we do that at Guild Audit. It's an on-site training. Like the course, ongoing course is also going, and then we also have this Starknet Security Bootcamp. So we'll be also having our next on-site course by 4 months or 3 months from now to come. So in part of what we do at Guild Audit, also we train cryptography engineers. Like we do that from scratch, like the math part of cryptography, because we're also seeing that is also a challenge to most Africans, right? So we try to see how we also incorporate that in part of our trainings. Yeah, so that's for Guild Audit. So for this program for Starknet Security, so we have like few people that are also, yeah, just like what Dickens said, Starknet is also like a new technology. We have few people also trying to just even come into the space, and not even just the security side of things, but basically just even to understand the technology itself. So at the same time, as you try to build technology, as you try to build products on this Starknet technology, right, there is also some security stuffs that has to be taken at hand, right? So we are also trying to see how we build, or we are building that community and that experts of persons who will be the persons to help in safeguarding products that are being built on this technology. So this is also like one of the things we're doing here at Guild Audit and with this bootcamp. So moving forward also, as we keep growing in this community, is that we're building a community of security experts on the Starknet ecosystem. So it's awesome to have you guys as the first pioneers of these things that we're trying to do, and well done to everybody here. I think that will be all for now. So it's just a very short call. It's just a very short training. We get to send assignments or tasks that you need to do over the week, and we just get to see how we get that going, right? Please join in the community on Discord. I think that has been sent to your email. Yeah, so an email has been sent to you. It's the link to the Discord, and then you could ask in your question. You could bring in every of your suggestion and how you think we can also build this community effectively. So it's not just for one person. It's like it's everybody that will have to bring all hands on deck. So your suggestion, your recommendation will also go a long way. Thank you very much, and that will be all for now. Thank you, Mr. Dickens.
Okay, thank you guys. You have an amazing night. Right now it's around 8 p.m. here in Kenya. So good night. See you on Friday. Compile all your questions and send it to our friends at Guild Audits, and then we'll be able to check out on them. And if there are any topics that you wish maybe we touch, because again, these are our first iteration, so feel free. We will definitely improve, and your feedback is highly appreciated. Good night, guys. Thank you. Bye-bye.
Yeah, bye-bye.